Hi folks, I'm out here with a realistic STA-77. I got this from the same gentleman that I got the Crown PSA2 power amp and the PVM 2600 power amps. He's got a bunch of stuff he's offloading, and I'm always looking for something to repair. And I never seem to sell anything. I keep joking I'm trying to make the leap between hoarder and extreme hoarder, and every day it's becoming less and less of a joke. I may have mentioned I was having a dental procedure Saturday. I thought I was going to be laid up, but I tell you what, my dental care practitioner is amazing. So got to give her a shameless plug, Dr. Colleen Lamb, Dental Arts of Atlantis. So if you're in the Palm Beach County area, I highly recommend it. So I took a cursory look at this thing, and I can tell you it's ugly. We got to have some fun here. Okay, as my usual practice, I fired up on the dim bulb tester. Everything looked fine there. However, I'm feeding in a sine wave into the left and right channels, and what's coming out is beyond ugly. Take a quick look here. So, I'm not sure exactly what's going on, but each channel is different. So, yeah, here we go. 0 watts at 10% distortion on the left, and 0.02 watts at a whopping 35.3% THD on the right. Yeah, we got some issues in here. We're gonna have to take a look at this. I haven't even checked any other functions, because if it doesn't amplify, what's the point? So we can pop the cover off, take a look at the schematic, and see what is going on here. This is the preamp stage of this little receiver, and it's kind of interesting what they do here, because all the signal goes through the preamp stage, and when you go to selector position number 3 here, which is the phono, it brings in the RIAA network. So what they do is they attenuate everything else that comes in, and the phono stage comes directly in. But the problem with all the distortion of both channels, and it's kind of interesting because they look different, the right channel was the one that was far worse. And the problem with that is this capacitor, which is 4.7 microfarads and comprises a feedback loop here, comes in and goes around and into here like this. That capacitor was essentially open. It's reading about 239 picofarads to 298 k ohms of ESR. It was a very, very, very bad capacitor. And when I replaced this, everything started to work right in both channels, and that kind of threw me for a loop. But I suspect that what is happening is this is the DC voltage that comes in, and incidentally, I checked all these DC voltages, and while they don't give them on this schematic, this is the schematic for the STA-77A. The unit I'm working on is just a straight 77, but the one with the L prefix has an identical stage, but they are kind enough to give you the expected DC voltages. And these all measured fine. It was only when signal was put in that we had a problem. And the DC voltage for this stage comes in here through this resistor, and it gets picked off here. And I believe what was happening is when you fed any signal in here, this thing drew so much current that it pulled down both channels, because replacing just this capacitor in the right channel completely straightened out all the operation. I replaced them in both channels, but the other one measures okay. So let's take a quick look at the ESR meter, and you'll see what I'm talking about. All right, to better help understand why a bad capacitor in one channel is messing up the other channel, I put the bad capacitor back in, and we have the same thing. We still have distortion on the left, but a tremendous amount of distortion on the right. The right channel is affecting the left channel. And you can see we have 30% distortion on the right and 1.8% on the left. Now, if I remove the signal from the right channel, our distortion on the left channel drops to 0.03. So the channels are affecting each other. And it's not happening at the input. It's happening, I believe, in the tone control board. But more importantly, I'm going to crank up the signal a bit here. So you can see, let me drop this down because that's over the rating of the amp. So there you go. We have 18 watts, 32% distortion. Now, if I drop the signal amplitude down We're going to drop it to 10 millivolts. Okay, now my meter auto ranges. So now we have 0.3 watts and 0 in the left channel. Remember, this thing auto ranges, so the amplitudes here can be deceiving. But I'm going to crank this up. Here you have it. 19 watts at 0.05% distortion. That seems great. Why would you even put that capacitor in there? And the reason for that is linearity. Because we have about full output here at 1 kilohertz. What happens at 15 kilohertz? Our signal drops down to a fraction of a watt. Whereas if we look at the left channel alone, and I put in an amplitude of 0.5 volts, and I'm going to turn this off because that's very distracting. And we drop our amplitude here. Let's go a little higher. Okay, 15 kilohertz, we have 15 watts a channel. 1 kilohertz, we have 15 watts a channel. That feedback capacitor, which if you recall, that was the function, is to keep our input stage linear. Okay, so that capacitor comes from here, goes through here, and winds up back at the emitter here. I'm going to do that again because apparently it wasn't in the frame. Here we go, that's a little better. This is our capacitor, that's bad. And our feedback path goes through here and into the emitter of the first transistor. Without it, we have no linearity. But the other question is, why is the right channel affecting the left? And it's not happening at the input. So I'm going to move the scope probe. We're going to talk a little bit about this. Okay, so looking at the output of the left channel, you can see we have a nice clean sine wave. So what's happening is not occurring in the front end. It's occurring, I believe, on the tone board. So this is the left out. This goes through the tone board, and then it goes to the output stage. And at the input of the output stage, here, we don't see anything with the volume down, but as we turn the volume up, we see this. And if I take the right channel out, it cleans up. Doesn't look great there because I'm overdriving that. Drop that a little more. And drop the amplitude on the scope. And you see we have a nice clean sine wave going in. But if we have the right channel connected, we get this. That bit of ugliness. So this is happening somewhere on the tone board. I just want to take a look and see if I can spot that. Okay, I think what's happening is we have this bleeding back through the balance control, because if I turn the balance all the way left, we get a nice clean signal here. I'm going to drop the amplitude because the right channel is in a hard clipping. But if we turn our balance here and turn it all the way to the right, you can see we got some real problems here. Take the right channel out, everything cleans up really nicely. So yeah, I believe it's bleeding through the balance control, and that's why a problem on our right channel was so negatively affecting our left. Okay, so now you can see on the scope, everything looks good. Remember, this analyzer auto ranges, so it's going to clip until it changes ranges. And we are, yeah, it's about max output. There you go. Puts out about, I think it's 20 watts a channel. So it's looking pretty good now. The other problem I was having is I was not getting stereo on the FM. Now I'll show you what the issue with that is. So let me set up the generator and I'll show you where the problem was. Okay, so this is the signal generator feeding into the FM. And I'm feeding an FM mono, and you'll see that we have left and right both in phase. But if I go to the next one, left minus right, we get this. If I go to right only, we get both channels in phase. Left only, both channels in phase. We're not getting stereo. So again, here's mono. And this should be both channels with one out of phase. And the problem is very simple. And that is the FM indicator lamp is bad. And without the indicator lamp, the circuit doesn't work. And I'll show you because I have these jumper leads going to where the bulb is fed. And if we put this on, and the bulb lights, now you'll see we have signals 180 degrees out of phase. Right only, left only, off, mono, 180 degrees out of phase. Disconnect the lamp, we lose our stereo. So the lamp is an important part of the circuit, and that was the only thing that was wrong with the FM. Okay, so with the front panel off, I pried up 4 prongs here and 2 here so I could get the burned out bulb out. There's a small piece of square rubber that sat in here. Pressed these down. They were also lightly glued in. And I took the bulb that I found that seems to be a good replacement, and I used a red marker to make it red, and it looks like it's going to do an okay job here. I set it into place and I ran it with the power supply. You can see it doesn't look quite as red in the video, but it's going to be okay. So we're going to put that into place and then put everything back. I accidentally nicked the wire to the good bulb while I was cutting the tie because it was really tight. So I got that soldered and I have a piece of heat shrink I have yet to shrink down. But looks like this is going to be all we need to do to get the FM straightened out. Alright, so I have both bulbs pressed down into the top here. And I'm going to clamp everything down. The new bulb is just a little bit larger, so I may have to trim the rubber piece a little. We'll see. I really don't want to have to do that, but this replacement electrically seems to be good. Now, with both bulbs in circuit, the white lamp comes on when we don't have a stereo signal. And it's really difficult to see from this angle, but when I get a stereo station tuned in, the pointer turns red. And I tried getting face on, but possibly due to white balance, it didn't look red. So I just decided to shoot from this angle. Additionally, what I've done is I have connected a milliamp meter in series with the lamp because the circuit specifies that the lamp be 6 volts and 60 milliamps. If we look here, you can see that. 6 volts, 60 milliamps. And the bulbs I have are 6.3 volts, 70 milliamp. And if we look at the meter, you can see it's pretty close, but I have a decade box in series here. And I discovered that if I add about 10 or 20 ohms, we can knock it down to a respectable level. That's right about 60. And that's 57. It doesn't affect the brightness of the pointer. Okay, it does a little bit, but I think I'm going to put 10 ohms in there just to be safe, because the way the circuit works is the FM multiplex IC syncs the current. That is, the current passes through the IC chip. It doesn't source it, it doesn't put it out. It passes through the IC chip, I believe, to ground. And therefore, we don't want to exceed the specifications. So in order to make sure that we don't, I'm probably going to put a 10 ohm resistor in there just to make sure. Now, it's not a lot over. It's 1.5 milliamps, but I don't want to stress an IC chip, and I have plenty of 10 ohm resistors. Anyone that's watched a lot of videos on my channel has seen me use this tool, but in order to get these strain relief bushings out, this is a tool I don't need often, but when I do need it, it's worth its weight in uncut diamonds. This is a strain relief bushing, set of strain relief bushing pliers. And with these, you can get these out without mangling them up. I used to use a pair of needle nose vice grips, and I could get the strain relief bushing out, but it usually scarred them up pretty bad. Now, since the camera is running, I don't expect this to go really well, but you basically just squeeze and rock it out, and the bushing comes right out. So yeah, absolutely worth their weight. So now I need to find a power cord that's going to fit this. One thing I do is I never throw out any wall warts to anything I'm scrapping, and anything that's AC power that I scrap, I cut the cords off of. So I usually have a pretty good selection. I can usually find what I need. I've occasionally had to resort to cutting up extension cords, but let's see what we got. All right, I've got this little guy all put back together, and it sounds pretty good. This is the phono input. I knocked the level down with this external volume control, and I used reverse RIAA media that I created in Audacity and burned to a CD, and that is a procedure I outlined elsewhere on my channel, but that's how I can play a CD through the phono input and have it sound correct. Nice little receiver. It's only 20 watts a channel, but in a small room with a decent set of speakers, this should sound really good. It sounds good through my bench speakers. Apparently I only recorded the 2 tracks on here. But if we go to FM, it gets a lot of stations. You can see the tuner needle changes color when we get a stereo station. And tuner has good sensitivity and good selectivity. Anyhow, that completes this video. It's kind of an interesting problem in that one channel is affecting the other, but everything else in here seems to work really well. And I got it all put back together, and I may actually even try to sell this. I got to start thinning the herd. I can barely walk around here. I used to joke about getting old, and then one day I woke up and it wasn't a joke anymore. I'm afraid the same thing is going to happen with that hoarder to extreme hoarder thing. So yeah, I think I'm going to try and offload some of this stuff. But anyway, I'm glad everyone, I hope you enjoyed watching this. And as always, I enjoy giving back to the community that's given me so much. Thanks a lot, folks.